Good morning and welcome to my presentation on automatic translation of spoken language to sign language. My name is Anirudh Joshi and I'm excited to share with you my work on this innovative project that aims to bridge the communication gap between people who are deaf or hard of hearing and those who speak different languages. The goal of my project is to create a reliable and efficient system that automatically translates spoken language into sign language, making communication more accessible and inclusive for everyone. I'm excited to share with you my work so far on this innovative project. I must emphasize that this is still a work in progress, but I'm eager to share with you the steps I have taken so far to develop a reliable and efficient system. In this presentation, I will discuss the challenges faced during the development process, the techniques used, and the progress made so far. My project workflow involves putting English language sentences into the machine learning model, which will convert them into sign language tokens used to trigger animations in Unreal Engine. To make the project scalable and accessible, I'll be using AWS for hosting, scaling, and managing the application. I'm also utilizing AWS Transcribe to convert speech to text, making the project more inclusive for those with hearing impairments. I have made significant progress in our project, but with a focus on AWS services, Unreal Engine, animation sequences, and WebSockets. Our next steps involve implementing of ML model, integrating it with the Unreal Engine, and deploying it to the cloud. One of the key decisions I made was to host the project on AWS, a cloud platform that provides reliable and scalable services for hosting applications. I have used several AWS services, including Amazon EC2 instances for hosting the backend server and Amazon DynamoDB for storing the data. In the course of my project research, I have learned about Amazon S3, which is a highly scalable and durable object storage service provided by AWS. I'm considering using S3 in my project to store the various assets required. In my research for this project, I have learned about Amazon EC2, a web service that provides a resizable compute capacity in the cloud. I'm considering using EC2 to host the backend server for my project. With EC2, I can easily deploy and manage the software required to run my project. During my project research, I have studied about Amazon DynamoDB, a fully managed NoSQL database service provided by AWS. I'm considering using DynamoDB in my project to store the and retrieve the sign language tokens generated by the machine learning model. DynamoDB is fast, flexible, and can handle large amounts of data, making it a good fit for this application. Yeah. Unreal Engine is a popular game engine technology that offers powerful tools for creating high quality animations and interactive experiences. I'm using Unreal Engine to create and render the animations triggered by the sign language tokens generated by the machine learning model in my project. I have developed my Unreal Engine skills by consulting various resources such as official documentation, online tutorials, forums, and Unreal Engine Developers Handbook. Uh, Specifically, I have read 7 chapters of the handbook to gain insights and techniques for creating high quality animations and experiences. As part of my project, I created control rigs and animation sequences for sign language gestures in Unreal Engine. I integrated them with the machine learning model using blueprints for precise character control and playback of relevant animations. WebSockets are a communication protocol that enables real-time bidirectional communication between a web browser and a server. I have studied and tested WebSockets in Unreal Engine and Visual Studio to enable live streaming of sign language animations to end users in my project. By integrating WebSockets with AWS services, Unreal Engine, and machine learning models, I aim to create an innovative and highly functional system for automatic translation of spoken language to sign language. This solution will provide users with a seamless and responsive experience due to the low latency, bidirectional communication, and scalability of WebSockets. I still have some important tasks to complete in the project. These include developing and implementing a machine learning model for language translation, integrating it with the Unreal Engine, and deploying the system in the cloud. I have identified a suitable data set and began exploring various models and techniques for implementation. I plan to start the implementation soon and will provide updates on progress in future presentations. Thank you for listening to my presentation on automatic translation of spoken language to sign language. Feel free to reach out to me if you have any questions or feedback. Thank you for your attention and interest.